So the make migrations is what reads the models.py files, and then it creates what are called migrations. And the key thing is this is guided by the list of applications in settings.py. So if you make a new thing and make a new application and you edit the models.file and you try to run and make migrations and it doesn't see anything, you're like, what did it just do? Well, did you edit your settings.py? Because there is a thing called installed apps in your settings.py. Now, migrations are portable across databases. This means that the migration is a logical description of what the tables should look like. And they're an evolution. What they mean is like the first version of this table from the first models.py when migrations was first run is 001. And then if you change models.py and you run a migration again, it looks at the changes from the migration 001 to models.py and then 002. And then 002 is not like wipe it all out and start over. It's like, oh wait, you just added one column, I'll go ahead and add that column. But it's not done it in a way that's actual SQL. So migrations are themselves kind of Python-like, and they're portable across databases, which means that you might on your computer use SQLite, and in production you might use MySQL, and the migrations are the same for both of them, because they're just saying, here's the columns, here's the types, here's what they're supposed to be. Now, contrast that with a migrate command. The migrate command reads all the migrations and then knows what database it's talking to and runs the SQL commands to create the necessary tables and or evolve the necessary tables. So it looks and says, oh, here's the first migration, here's the second migration, here's the third migration. I'll make the table, I'll change the table, I'll change the table, I'll change the table, and at the end of all the migration, the migrate then goes through all the migrations and then has a database table that reflects the sum total of the migrations, which also reflects the latest models.py file. So it's a little complex. It has to do with database portability and the fact that we want to separate out the portable parts of this from the non-portable parts to this. So if you look at the make migrations, and here's in DJ free samples, my little sample stuff, there's lots of models in there. And if you take a look at all the models.py, you see that for every application in the DJ free samples project, you see a models.py file. And that's a Python code, that's class, book, blah, blah, blah. That's very portable, and that's how we, in our Python code, in our Django code, see the database model. And when you run the make migration, that produces these migrations files. And they're just in like autos migrations, 001 initial.py, etc. And so you see some of the ones I have here, there's actually two of them. So it sort of made the first one, and then I must have changed the models file, and then I ran make migrations again, and it showed, it recorded how that model changed from the first version of the models file to the second version. If you can look at these, don't edit them, you can check them into GitHub, but don't edit these, but take a look. They're a very portable representation. They kind of look like the models.py file. You're not supposed to change them, you're supposed to generate them with make migrations. And again, those can go into GitHub. Now, the migrate basically reads all those migration files. And not just one, but if there's a sequence of migration files, it applies them all in order as needed. And if the database has the first and second migration applied, but not the third one, it knows that and says, you know what, I'm going to just tweak this database that already exists, that's already running, and then add a column or change the width of a column or whatever it is that you've asked to be done by editing your models.py. So when the migrate is done, you then end up with a whole bunch of tables in your database. And they're all based on the name of the application and the name of the model within the application. And so somewhere in here is book one book, book one instance, and book one lang. They're all sitting there. And so those are all the tables. And we took a look at those tables before, but that's the migrate. That goes from all the little migrations spread across all of the applications in this project and then puts a database together that has all those things. And I keep saying that the migrations are all about evolution, right? Because if you take a look here, you see one little table called Django migrations. And what Django's doing in that Django migrations table is remembering which of those migrations have already been applied to this database. So as it's going through the migrations, it says, oh, here's one that's not yet done in this database, so I got to tweak the database just a little bit. So it remembers the migrations that have been done. It's pretty fascinating, and in these little tiny applications, we don't always need to be so clever about that. So sometimes what you want to do is just like, I'm confused. I'm going to rerun the make migrate, because you're not really running production, you're just really doing it over and over again. So you can rerun the make migrate. And the way you do this is you basically simply delete the file. You can delete these files. I would delete all the ones that start with 0, right? If you're going to rerun make migrate, just rerun make migrations. Delete all the ones that start with 0. And this is in application migrations, and then get rid of all these. And then you can rerun the make migrations, and it will read your models.py file, and then it will do all of the necessary things to recreate the migration file. Right now, that's not the database. That is the instructions on how to create the database. Okay, so that's how you rerun make migrate. You can run migrate from scratch. This is actually easier. So you can kind of wipe out the migrations for one application, and I did that, just wiped out the book 1 here. That's what I did and started over. But you can wipe out all the migrations and all the database and everything by just removing the file. In this case, because we're running SQLite, just wipe out the file rmdb.sqlite, because after migrate, that's where everything ends up, is in that file. So then you wipe that out, it's gone. Now you might have created an administrator account or something, and you're going to wipe that out too. You're going to wipe the data out, you're going to wipe the tables out, it's all gone. That's one thing I like about SQLite. You remove this one file and it's literally all gone. And then you rerun Python manage 3 migrate, and it reads all the migrations and makes you a nice, clean, perfect, empty database. So if you're kind of stuck, and you're not afraid of losing your data, which in most of the beginning programmers, it's okay to wipe out your SQLite thing and run migrate again. Just go ahead and try it. Like I said, if you made an admin account, well, you got to make it again. But that's the worst that you can do. So at least in these beginning applications. Hello and welcome to another Django for Everybody walkthrough. This walkthrough is the 04 Model 1. This is a walkthrough where we're going to talk about one-to-many models. And this is a situation where you have 2 tables, and there is a one-to-many or many-to-one relationship between them. And this is all in my Django for Everybody DJ for eSamples. You can track it's public, you can check it out, and it's in the tracks project. So I'm going to go into DJ for eSamples, CD tracks. So here's so I've got tracks, I got the tracks model, cat tracks model, models.py. So this is a model. We went through this in the lecture where we built this model. There's an artist, an album, a genre, and most of these are kind of simple. These are kind of, this artist is no different than a single table, but this album is related to, and this is where this foreign key comes in, that says there's an artist field inside the album table that points to a particular artist in the artist model. Okay, so it's the artist that belongs to this album. On delete, set null. That basically means if an artist gets deleted, will the album get deleted? And null equals true means that we allow this to be empty. We allow there to be an album without an artist. That's what null equals true here. On delete means if we delete an artist, do we delete all their corresponding albums or leave them? And this says if an artist gets deleted, we're going to sort of clear out the artist in the album table. The genre table, again, just has a single field. And the track table has 2 foreign keys, the album foreign key. And what we're going to do here is if we delete, on delete cascade means if album gets deleted, we are going to delete all the tracks. And on delete equals set null for genre means if like a genre like rock and roll gets deleted, we're not necessarily going to delete the track. We'll just have a sort of an empty genre here. So that's what this on delete. It's the on delete of an album entry or a genre entry and how it affects the track entry that we've got. Okay? So we've got this put together here. And we're sitting in here, and we've got our model. We could say Python 3 manage.py make migrations. But since I checked this out of GitHub, the migrations are already in there. And then if I say Python 3 manage py migrate, it'll actually do a bunch of work and make us a database, including all of the tables that are part of the tracks model. So now if I have a dbsqlite 3, and if we were to take a quick look at that, like sqlite 3 db.sqlite, and we say what tables, we'd see there are all these tables: tracks model, album, genre, and track. And if I say like schema tracks model.track, you'll see that it's got some indexes, it's got these things, it's created a bunch of SQL that represents that model. So we'll get out of that for a bit, because we're not really here to do SQL. We're here to do the object relational mapping. So we're going to start the Django shell. And again, some of these Django shells have different user interfaces. Some of them have arrows. This one here has this little prompt. And so we're running Python basically. So we have to import our models. This tracks model.models, that is sort of in our Python, and the manage.py knows how to set the paths up. So we're in the tracks project, and we're getting to the tracks model application.models, and we're importing 4 models. Now these are classes that we're now going to start making some objects. And we start by working from the farthest out leaves of the tree and working inward. And we're going to store all these things in, I'll just grab all 3 of these. I think it'll paste pretty nice. Yeah. So this creates a new artist in memory with the name of Led Zeppelin. And then I'm going to have this in the variable Zep. And then I can send it to the database, save it, and say get the ID, which was the primary key that was assigned to this, as 1. Now later I'm going to use this variable because I'm connecting models to each other. So the next thing we're going to do is, and the names of these variables are just variables. Sometimes I use mnemonic ones, sometimes I use silly ones. I made an artist called ABC for ACDC, but the variable's ABC. Be careful, this is just a variable in Python that we're using. This ACDC is data we put into the, if we do abc.id, oops, we get a 2. Okay. So if we say, well, how many artists, what's in the artist table? This at this point is just a single table thing, and we can sort of see what the primary keys, those ID fields are the primary keys that were assigned. And so the next thing we're going to do, this one here is the tricky one. So we're going to create an album. Now albums has a title, which is just a string, but it has an artist field, which is an artist. And so this is who made who, and the artist is ABC, which is this variable, right? This title could be a variable too. This variable is an artist object, right? And so we're saying connect this album to AC/DC, right? That's what we're saying. When we made AC/DC, we retained that object and its ID in particular, and we're going to make an album and connect it. Then we have to save it, or it doesn't go in the database. And then we're going to make a Led Zeppelin 4 album. And we're going to give it a title and use this variable Zep, which we created up in here. And then we save that. So we've got, if we take a look now, we say what is in our album table? Album.objects.values. What's in our album table? So we type that, and we see that we've got 3 albums. And you see this field here, artist_ID. That is a convention that says that's the ID key in the artist table. That's a foreign key. It's in the album table, but it points to a key in the artist table. So they name it artist_ID. It's a common pattern in object relational mappers, and as a matter of fact, it's a common pattern for people who use SQL to use this pattern. So it just signals right away, I can look at this and know on hundreds of database tables what that means. That is, oh, that's a foreign key into the artist table just by the name of it. It's a convention that the Django object relational mapping enforces, but a lot of people follow the convention even if they're not using the Django object relational mapper. But we now have two objects and they have connections into the artist table. So this is the important part. It's the part you should understand, where you're creating a foreign key, but when you're doing this new album, you got to have this variable present. It's got to be there. Okay? So let's make a new genre. Let's make two genres. And again, these are just variable names. So I've saved those. I could do genre objects dot values. And we can see what we put in genre, but that doesn't surprise us, right? Okay, so now we get to the big deal right here. So we are going to create the track, and the track, if you recall, the track has two foreign keys, both a genre and an album. So when we create our first track, the album is the variable ZEP4, which we made right here, and the genre is rock, which is the variable we made right here. Okay, and so that's how we indicate that the genre is rock. And we do that. The title, rating, length, and count, they're just standard fields in this. And then we say x.save. Boom. And then we got these other ones. But the pattern is the same. They're just, when we have foreign keys, we're referencing variables that are themselves the right kind of object. Album equals ZEP4. That's an album object. Made is an album object. Made is an album object. Met is an album object. A genre object. And rock is a genre object. So I got these, constructed correctly. That's why I gave them to you and didn't make you type them. And now we can take a look at all the tracks we've got. And so it's a little hard to see, but we've got a query set, which is a list. The first object is ID 1, black dog, rating 5. Count, album ID, first foreign key, genre ID equals 1. So those are the pointers into the primary keys of the album table and the genre table, respectively. And if you go through this carefully, you see the second one, ID 2, Stairway to Heaven, ID 3, About to Rock, ID 4, Who Made Who, rating, with an album ID of 1 and a genre ID of 2. And if you carefully get it right back, you know that the AC/DC things were metal and the genre is rock. Okay? So now we have set things up, but now we can also look things up. So let's just say we're going to grab that one with a primary key of 1. That's going to be black dog here. Track objects get primary key of 1. So that's the variable first. And I can say first. And that tells us it's a track. If I say print first, it uses the stir method, and then it gets to the black dog. Okay. Now the stir method is __ stir method is what decides which of these fields shows up when we print that out. That's why the stir method is important when we're defining models. Now we can say print first dot ID. We can say print first dot length GHT. Got that right? Oh, then GTH. Okay. But we can also print first dot genre, which is rock. We could be even more clear to say first genre name. So first genre is a genre object, and name is an attribute of the genre object. We can say print first.album.artist.name. So that says first is this object that we've got, which is this object of the track Black Dog, and then album is the album associated with that track, and then artist is the artist associated with the album, and name is the attribute of the column in the artist table. Okay, and so this is an object, album is first is an object, album is an object within first, and artist is an object within album, and then name is a column within artist. Okay, so I hope that was interesting to you, so that you could see how a one-to-many data model could be worked with and used. Hello and welcome to another walkthrough for Django for Everybody. This is kind of a supplement to Tutorial 2. In Tutorial 2 you're playing with models.py, and if you go through the tutorial they'll have you do a thing and then they'll do another thing, and they're kind of showing you migrations and how the migrations happen. And if you get them to have a mistake, if you make a mistake, then you can get to the point where you need help or whatever, and sometimes it's easier to just like wipe out your database. But if you've added a question or added some choices or built models, you got to do all that stuff. But it's sometimes just easier to redo some of those things. So I'm going to show you what to do if your model/database gets messed up, and like your manage.py make migrations and migrate are not doing what you think, or they're giving you weird errors. Now if they're getting a syntax error, make sure you do a Python manage.py check right before you declare that your database is messed up. So let me go into my go into my site. So here I am. Here's all my files. So here I should do it before I declare that the database is a problem. Manage.py check. Oops. Oh, I messed that up. I'm in my virtual environment, of course. Okay, so we got no issues now, so that's good. So I got a couple commands here. Let me explain this. Before I'm going to actually delete these, I want to show you where the migration. I probably showed you this. So I have a thing called polls 2, and I got all the polls running. So this is like in tutorial 2. The migrations are in files with a number, and they're Python files. So if you recall, migrations are portable representations of what happens in the database. And then the migrate creates the file db.sqlite. So you need, if you want to really start over, you got to get rid of both the migrations and the db.sqlite file, and then you can start completely fresh. You could sort of do parts of them, but I'm like, if you're messed up here at tutorial 2, it's probably easier to just get rid of them both. So at this point, my application is going to stop working. So I get rid of the migrations, and then I get rid of my database. And so at this point, the only thing I got that has to do with anything to do with my database is a few models.py files. And this is where we are editing our code. And so this polls2 models.py in my particular example is the code that's going to be effective, because I've got all the versions running at the same time. That's why you're seeing this. So the next thing to do is Python 3 or Python manage.py make migrations. So what make migrations is doing is it's reading all these models.py files, and it's writing this file. So I got rid of that file, but now if I do an ls, you'll see that it's come back. And sometimes you might see an O2, etc., and then you throw it away, and you make it fresh, and you should only see an 001, and then you can say Python manage py migrate. And then that, well, if you do an ls, let me control C there. If I do an ls, you'll see that there, oh, wait a second, how come that, oh, the DB SQLite 3 is 0 size. So I'm going to do Python 3, or Python manage, sorry, my Mac, migrate. So that's reading these files, plus a whole bunch of other ones, and actually creating databases. And so now if I say ls-l, my DB SQLite 3 is back, and I might have to create a super user. If I created a super user account, then I'm going to have to create one again, right? And so I'm going to do that. EJ4E, chuck, c7@umesh.edu. I should make my passwords easier to type. Now at this point, things should start working. But again, if I created any data, like a question or something, it was gone. It was gone at that moment. When I got rid of that database, DB SQLite 3, it is literally gone. So it's gone now, and away we go. And so and again, this is just if you can't seem to make these migrations or migrates work, back up, start over, and then redo some of the work. And that probably will be a good way to get things done. Cheers. Hello, and welcome to our lecture on data modeling. We're going to have a couple lectures on data modeling. This first one is sort of the one-to-many, which is the easiest to understand, and then we'll have another lecture on many-to-many. Just to give you sort of, we're still sort of building a Django application one piece at a time, and we haven't built a whole Django application. But basically, we're really focused on model.py and a little bit more on admin to inform. So model.py is where we define the structure of our database, and we see this database through data models, data model objects, and we can register our data models in admin.py. There's not too much in this admin.py. But we really, and so we're going to be talking to things like the shell, or you can even run scripts in here. So the whole thing in this lecture, we're not talking much about the routing or the views or forms or templates. So we're really focused down in this area of our Django application. And it's okay, we'll get to the rest of them. And we're just kind of talking about the data modeling now. So I came to databases late in life. I saw them a little bit in grad school, which is a very long time ago, and I didn't like relational databases much. And I went to a job, and I had to learn relational databases for the job. And luckily, I actually was pretty advanced programmer at that point in time. And so they taught me how to do data model design, and I picked it up really fast, and I totally fell in love with databases. And so model design is a interesting problem to solve. The basic idea really comes down to efficiency of storing and retrieving data. And it just comes down to, like, if you build an online application like Facebook, and if you're not clever about how to store your data, and somehow every time you logged into Facebook you had to read all the Facebook's data to find you log in, it would really literally take you 2,000 to 3,000 hours to log into Facebook if it had to read all of its data. Now obviously millions of people log in per second in Facebook, and so obviously they're a little faster than that. So somewhere between, days and days and days to read the data, and can read the data a million times a second, in there is where databases win. And so at times it seems like when we're building a data model, you're like, oh, this is so difficult, why are we working so hard? And the answer is you just can't scale. I mean, you can read through your data for simple data mining things, but databases are really important. And especially when you're building interactive online applications, speed's important. So it turns out that, like most things in database, you can learn the basics pretty quick, and the rest of it is sort of an art form that you learn as you go. And so the goal is to figure out the data that you want to store in your application, and then draw a picture spreading that data across multiple tables and then creating links between those tables. So you kind of start with a sample data set. Now this is where we're going to end up, and this is the model for the data for this local library application that we're building, and this is the thing we're going to keep coming back to over and over. So this is the destination, but we're not going to hit this destination. We're going to start more with the data. Now different applications, when you work at different organizations, you're going to find that the data model is very important. So this is the data model of my auto grader, which is based on a framework I built called Sugi. And so if you were to learn this thing, early on I say, oh, and here's our data model, and here's how we store stuff, and here's this, that, and the other thing. And this data model took a lot of time to get right, and it's a real important part of the application. And another project I work on is called Sakai. It's a learning management system that's open source. And you know, this is a tiny fraction of the data model, but if you want to work in this application, you want to improve something or add a feature, you got to figure out this data model, because where the data goes, it shows up kind of flat in the user interface, but eventually it's stored in very specific locations and linked. And that's why you see all these little boxes, but then lines. The lines are also the links between the various tables. So there's a whole bunch of theory about database normalization, and it's important. It really is. And if you take some time, go ahead and read about it. First normal form, second normal form, third normal form, version A and stuff. I'm not really into the math. I don't really want to explain the math to you. The key thing about database normalization, ultimately, that it can be sort of distilled down to: don't replicate string data. And what I mean by string data is like names and URLs and things like that. So in a system, ultimately, if my email address is stored in text in that system, it literally should be stored once. There should be no email address, email address, email address. What you need is to have the email address one place, and then kind of give that email address a number, and all the places you want to indicate about that email address, you use the number. And so these integer numbers are the key. So we create keys, which are the lookup handles, and then we point to those keys. And we use integers to make links between the tables, because integers are fast. They're the thing that computers understand better. Computers understand and move integers around. They use less data, they calculate, they compare really fast. And so integers are very important. So now let's design a data model. Usually you start out with a user interface that, if we're going to build an application, you're going to end up with a user interface. In this, I'm not going to really start with a user interface. I'm going to start with like a spreadsheet view. And if you've ever done something like tried to organize your music collection with a spreadsheet, or a video collection with a spreadsheet, or you find that spreadsheets are super convenient because you can scroll around and do stuff, and you've learned SQL, you can go into various cells with SQL, rows and columns, and update and do all this stuff. But you find that after a while, you start repeating yourself in spreadsheets, and you find it's really difficult, because it's really easy when you're putting data into copy, paste, paste, and put the same stuff in. But then what if you want to change it? And this is where this vertical replication, or the replication of data in multiple places, is very bad. So here's kind of an exploded table view of that same data. And it's okay. This is the data that we've got to do. And so if we look at the use cases of our application, what we see is there's a series of books. Like in this course, Wisdom of Crowds is a book, Introduction to Networking. These are all books coming down here, Unlocking the Clubhouse. So the first column is titles of books. The second column is the ISBN. And then we are sort of keeping track, because we're a library, and so we might have more than one book, and we're going to call those the book instance. So instance 1, instance 2, instance 3. Each book, each physical actual book, you might have no physical books actually, or you might have one physical book or 5 physical books, and each physical book might be checked out and have a due date. And so we have a status. And then we have something like, say, the language of the book, or the genre of the book, or who wrote the book, right? And so that's kind of the data we're going to represent in this application. Now, when you're looking at this, the first thing you do is you go like, anything where you've got vertical replication is a problem. And so you've got to be careful. So you look for vertical replication. And the places that are problematic in this table view of all of our data, like the status, the language, the genre, you see the word think. Those are strings, right? They're not numbers. Okay, wisdom of crowds, wisdom of crowds, wisdom of crowds. And the problem here with wisdom of crowds is that there are 3 instances of the book, but then because we've got this all in one row, one table with just a bunch of columns and not multiple tables, well, we have to replicate the name wisdom of crowds 3 times so that we can represent the 3 instances. The same is true about the English language and the genre and the author name, right? These are the same authors. Okay, so this vertical replication is your first clue that says that you've got to come up with a smarter data model than just this. And so the idea is you're not allowed to put something like the string EN, English, in more than once in your whole database. So what you have to do is you have to split this all out. Somehow you have to remove duplication by making a language table, a book table, and an instance table. And so in the book table you only put wisdom of crowds once, and you only put the English language in once and Spanish in once. But then the problem is, okay, somehow we've taken this data and moved it from one big long bunch of columns to 3 tables with sets of columns. But we still have to represent all the original data that we were working with before. We have to represent all that stuff. And so this is where we have to be able to make connections. And this is the essence of relational databases, and that is they don't replicate data, but they make connections from one data item to another data item. And so what we're going to do here is, in the case of the wisdom of crowds, we are going to have 3 book instances, but somehow they all point to one book in the book table, right? And so we have 2 books that point to the English language and 1 points to the Spanish language. Now this seems like, wow, that wasn't such a big deal, but when you do millions of records, it actually matters. It's the string data that gets you in trouble and requires far more scanning and far more storage. And another thing that happens is when you follow this rule of only 1 copy, well, what if we wanted to turn this to uppercase EN or something? That means as long as the data is linked rather than replicated, that means you're only changing 1 copy, okay? So the replication has a performance advantage, has a storage advantage, and it has a modifiability advantage when there's only one place. If we mistakenly misspelled the title of Wisdom of Crowds, it's easy, we fix it. It's not in these other tables. Whereas if we misspelled the Wisdom of Crowds here, we have to go find on the top one where it's just all one big long spreadsheet. We got to go and like do a search and replace. But what if that's in a different column? And so the idea of getting to the point where we have unique rows and we connect those rows. Now, I haven't told you much about how this magically works. I just said we can draw some arrows. And so by drawing those arrows, we got to show you how those arrows get drawn, because that's really important. So this is how you start drawing the picture of your database. And so the kind of relationship we're going to have between tables is like a many to one. So when we say many to one, what we're saying is that there is one English language entry and then there are many books that go to it. So that's a many to one relationship. So it could be just one, but it's many. And if we look at the data model that we see from the Django example from the Mozilla Developer Network, we can look at this and we can see here, right? This connection between the book table and the language table has 2 ends to it, and it has a direction to it. And one end says 0 ... asterisk, and the other end says 1. So this is many. 0 ... asterisk means a number between 0 and infinity, including 0, which means it's possible for a book not to have a language. We call that null in database concept. So there's a book with no language, or many books can have one language. So there's one language, English, and there is as many books as we want, including potentially 0 books, right? So we might have a language that has no books in our library with that language, and that's okay. So in this one, between book and language, it's okay to have 0. So 0 through infinity on the book side of the relationship and 1 on the language side of the relationship. If then we look at the relationship between the book and the book instance, now remember what the book instance purpose is to record the fact that we have the actual physical copies of the books that we have. And so we might have multiple copies. And so if you look at this, it's pretty much the same in that there is any number of book instances from zero until infinity. And you could have a book in your book table for which you didn't actually own a physical copy, and that'd be okay. We would know things like what its author was, what its genre was, etc. And then we would buy a copy of said book, and we'd add a copy to the instance table, and then we'd link that into that book. So again, you can have 0 book instances, well, 0 through infinity book instances mapped to a single book entry. Okay, and so this little legend, 0 to infinity to 1, is how we read this table. And you will see database tables that have different syntaxes, but they all are capturing the same thing, and that's the cardinality